Hi, my name is Scott Brown. I'm the Vice President of Product Management for Media Acceleration Technologies at Akamai. Today we're going to talk about how quality and performance drives engagement time for OTT audiences. In this webinar, we're going to talk about the growth of OTT impacts over the Internet, the relationship between OTT video quality and viewer engagement time, and how Akamai Media Acceleration works to ensure the quality of OTT streaming over the Internet. TV audiences are moving online. We expect global OTT video revenue to double between 2014 and 2019. And in 2015, global OTT subscriptions surpassed 100 million subscribers, reaching mass market acceptance. So let's talk a little bit about what impacts viewing time for viewers. There are really three components that we look like that affect viewer engagement time. The first is buffering. When you start a video and you get the spinning wheel that gives you a little buffer. Also startup time, and then the number of times the bit rates switch inside the viewing duration will also cause some issues. So each rebuffering event reduces viewer engagement time on an average of 14 minutes. And that means that viewers are going to watch for less time if you get a buffering event. Startup time is also important. If you get a 5-second delay in startup time, then 25% of your audience may abandon. By 10 seconds, that's 50%. So we have to really control startup time of that video so that users get the experience that they get on their TV when they change channels or turn on the TV and see video instantly. The other one is bit rate shifts, and those can increase in bandwidth rates by up to 4x. So we have to be very careful about that and try to keep the quality as high as possible for the viewer. The real point here is that engagement in view time drives increased content monetization opportunity for our customers, basically, and that drives their top-line revenue. So we have to figure out how do we increase that engagement time? What can we do from a technical perspective and from a service perspective to increase that engagement time and give our customers more opportunity to monetize that content? The real challenge that we have is answering the question, how do we get the quality and the reliability of a broadcast TV experience, but do that over a best effort internet globally? So most broadcast television today is managed, and companies spend a lot of money to make sure that there's no interruptions on those lines. But the internet is not like that. The internet is best effort and unmanaged. So we have to make up for that by building technologies that make the internet behave like it's a managed network. If you look at the technologies that we work on to do this, you can break them up into two spheres really of technology. The first side of it is stream acceleration, and the other side of it is network efficiency. So the stream acceleration side, what that is that's the technology that kind of makes the streams reliable over the internet. It gives us much higher quality video than traditional technologies today. It also has some interesting properties where it gives us more reach into audiences. So it gives us physically more global reach out to the audiences, but it also allows us to penetrate the audience in a better way. So we can reach more subscribers than we could with traditional technologies. The next piece of this is network efficiency, and these are technologies that we build that help operators and ISPs deal with the amount of traffic that is coming from consumers switching from broadcast to broadband. These technologies will allow them to more effectively utilize the capital investments they've already made so that they have a longer lifespan, and they have to do less upgrades on their network because we can make the network that they have way more efficient. It's really about kind of taking traditional broadcast principles and now applying them to the best effort internet side. So let's talk a little bit about the challenge that we really have from a technical perspective with traditional technologies. So all traditional streaming technologies today are built on TCP or HTTP. And these technologies are built for reliability. They aren't built for speed or throughput. And they actually trade off. So they'll trade off quality for reliability. If for some reason I miss a packet, I will lower my speed in order to make sure I get every single packet or every single package. The other thing that's interesting is the farther away the server is, or the round trip time, the less throughput that I can get through that pipe. So as an example, at home I may have a 20 or 50 megabit broadband connection, but depending on how far the server is away from me, I may only be able to use a fraction of that bandwidth. The distance away from the server dictates how fast or how high of a quality I can get the stream. And the other thing is congestion. If I experience a problem on the link, then TCP will also constrain me so I can make sure I get every single packet, not get the speed or the quality. So what that means is that HTTP throughput is constantly changing as I'm watching video on the internet. And the picture below kind of depicts what that looks like. The outside of the pipe is your 20 to 50 megabit broadband connection. But the inside of the pipe is what your TCP throughput may look like based on distance or round trip time or the packet loss or latency. So as TCP experiences problems on the internet, it will constrict the flow, and you will normally you would get a buffering event or something like that. Now, technology has evolved over time, and the advent of adaptive bitrate technologies has come about to solve this very specific problem. What those technologies were built to do is to reduce the quality of the video during these times where TCP can't deliver the throughput in order to visually degrade the video instead of getting a buffering event. But what we want to do is try to fix that. Viewers aren't used to seeing that on TV, and we want to make sure that their broadband experiences are very much like their TV experiences. So that's what our aim is, to figure that out. Just to give you some backdrop about how that really plays out, I mean, the concept of it is clear now, but we want to try to put some real meat on the bone of what impact that is. Akamai, on our global network, we see round trip times on average here in the United States of around 72 milliseconds and globally around 94 milliseconds. So let's talk about how that translates into throughput impact with a problem. Let's say we have a broadband speed of 20 megabits at home and a round trip time to the server of 72 milliseconds. That was the number for the US that we just talked about. If you have 0% packet loss with a standard receive window of 64K, then your TCP throughput, the max throughput that you can get on one TCP session there is only 7 megabits. Even though you have 20 megabits at home, it would be 7 megabits that you could get through. That's a 7 megabit stream that you could watch. That's an HD quality stream, so that gives you a sense. If there is 1% packet loss on the line between you and that server, then your throughput is reduced to 1.62 megabits, and that's barely a standard definition stream, even though you have 20 megabits at home. And at 3% packet loss, which is common when you start taking into consideration Wi-Fi in the home and Wi-Fi trying to travel through walls, and if you're walking around your house, at 3% packet loss and 72% round trip time, then your throughput is only less than a megabit. So these are real problems out in the space today. They're impacting our customers, consumers, and we need to figure out technologies to work around that. With these congestion and latency problems, basically, this challenge is only getting worse as the bit rates rise. People want to see higher quality 4K streaming, and as OTT audiences get bigger, this problem just exacerbates and gets more and more difficult. So at Akamai, we're developing stream acceleration technologies, and they're designed to get the reliability of TCP and the throughput of UDP, basically. So UDP doesn't suffer from the constraints of TCP-based protocols related to latency and packet loss, but we do have to do quite a bit of work to add the resiliency to it so that we can get the reliability of TCP. What this is going to result in is much more higher quality streams. The streams are going to be more stable at the highest bit rates, so they aren't going to move up and down in bit rate as much as a normal adaptive bit rate stream, so it's going to be much more like a TV quality experience. We're going to experience far less buffering, and all of these things together are going to get us to the ultimate goal for our customer, which is to extend the viewing times. We're going to drive up the viewing time, which gives our customers, again, the opportunity to monetize, more monetization opportunities for our customers, basically. This is some data where we show that more consumers are watching longer on Akamai acceleration technologies. Now, this data was taken from some of our production customers, and what it's showing you is viewers watching on Akamai streams against some other leading CDNs in the space. Along the bottom, you'll see the play duration in minutes for how long people watched, and the vertical line is showing how many viewers were actually watching. And what you'll see as a trend is in each one of the play duration segments, 0 to 2 minutes, 2 to 5, 5 to 10, is that Akamai viewers on the acceleration technologies, always there were more viewers watching for longer in duration. And again, what that equates to is the ability for our customers to monetize that content more. We also have other data that shows the other major factors in engagement time, which we talked about, which were rebuffering, startup time, and average bit rate. You can see here that in each category, Akamai is outperforming standard traditional technologies. So now we want to show you a little bit about how Akamai acceleration works. One of the important things here is that we want to get the streams into this technology as soon as possible, and we want to keep the streams in this technology all the way to the device at the last mile. So we want to create an end-to-end workflow where we can get the highest quality video at every step in the delivery path. So the first thing that we do is we provide the customer a small piece of software that sits on or next to their encoder called the accelerated broadcaster, or the Akamai broadcaster. And this technology basically will pull the HTTP streams from the consumer, or they can be pushed to them. But the important part is right there at the origin is where we get the streaming video, and we package it in our resilient stream acceleration technologies. That means over the first mile, going from the encoder or the origin up to the accelerated entry point, we're going to have an accelerated stream. That's the most important place. If anything goes wrong there, the entire audience is impacted. So we want to make sure that that first mile is as high quality as possible so that we can guarantee a high quality experience to the consumer. We'll then distribute this out to our distribution network and facilitate that the technology accelerates the stream all the way down to the last mile. Now, there's some neat things about this technology. We talked about the acceleration side and the network efficiency side. This technology is structured and arranged such that the client is in control of the quality, essentially. So the software that is running on the device is actually choosing the best quality sources that it can get from a consumer's perspective. So the way this works is that the client technology will tune into the stream, and at first it will talk to one of our many Akamai servers basically to get the stream. But then what it will learn about is many other sources that it can get the data from. And it will begin to contact those sources and try to create a mesh of high quality sources, so that if one source were to have a problem or to go down, it can instantly pull data or substitute data from another one of these sources. And the neat thing about this is that those sources can be very, very flexible because we've built the technology to work with IETF standards in the space. So as an example, we can be first talking to an Akamai server to get the stream, and then we may learn about a native or AMT, automatic multicast tunneling, AMT source to get the stream, so we can actually connect to a native multicast router on a telco or ISP to get the stream. And that makes the stream incredibly efficient for the telco. We can also even pull small bits of that data, resiliency data, from other people that are also watching the stream at the same time. And we can move between these sources. So if one is problematic, we can instantly switch to the other. And the viewer is always seeing a very, very high quality stream. So it's really about using the stream acceleration technologies to get very, very high throughput. We use multiple sources to get a very resilient mesh of sources so that we always have good sources to choose from. And then we have used IETF standards like native and AMT multicast in order to leverage the fact that we can help ISPs and telcos get the most out of their networks. The key takeaways from here are, as TV audiences shift online, delivering high-quality video becomes increasingly challenging. Traditional technologies that we use today, TCP-based technologies, they trade speed and throughput or quality for reliability, making it suboptimal for the future of OTT, basically. So Akamai stream acceleration technologies that we're developing are designed to get the reliability of TCP, but the throughput and quality of UDP, resulting in broadcast quality experiences over best effort broadband networks. So in conclusion, thanks for giving me the opportunity to explain a little bit about where we're headed. I hope this has helped you gain a better understanding of media acceleration technologies and how they facilitate the evolution of broadcast viewing to broadband. We welcome the opportunity to work with you to increase the quality of your OTT services and ultimately improve your consumer engagement. To learn more, please visit us at akamai.com/OTT.